Whatever we said in the last video, we have packed them up in a single function called process. So let's quickly go through this. We first compute the mean of all the variables. Then we subtracted the mean from each of the variables to get the center data, which basically means we shifted the origin to the center of the data. Now the affine subspace is a real subspace of dimension 49. Then we did that trick to compute the eigenvalues and eigenvectors of the covariance matrix, and the end product is this Q, whose columns provide O and B of size 49 of that subspace, and we also expressed all our 50 points in terms of this O and B's, the scores stored all the coefficients. Now I return all these informations in a single list. I have the list has the component center, which stores the mean value, O and B, which stores the O and B Q matrix, another field called scores, which stores the scores variable. I have used the same name scores for both the variable as well as the name of the field, which is allowed in R, and also I am storing the eigenvalues that I got. So the 49 eigenvalues. Well, in this case, actually, all the 15 eigenvalues, all the 50 ones, all the 50 eigenvalues, the last one being nearly 0. And I have created this function, so I shall just load this one. Let me just see. What I will do is, I will call this the new coordinate. So I will call it new coord equal to process X, and it did everything. And I call it new coordinate because it gives me a new origin, new set of axes O and B, as well as the 50 points given in that way. Let me quickly see if I have all the components that I wanted to create. Names will list the names of a list. So I have got center, O and B, the scores, and the eigenvalues. Fine. Now I am in a position to show the things. So what I am going to do is, I have each photo is now made up of this, the mean component, the very mean, the very center of the data, plus all those contributions of the 49 basis vectors. The first basis vector has the maximum contribution, the second basis vector, the next maximum contribution, and so on. So I will keep on adding them, and I am going to show them using the function show steps. The first thing is, I will extract the mean X, I will extract the O and B in a matrix called Q, the scores and the values. So I just extract everything from my new coord object. Finally, what I am doing is, I am creating a percentage. I call it the explanation percentage. It is cumulative sum of all of the values divided by the total values. So basically it is, if these are called lambda 1, lambda 2, lambda 3. So maybe I will just give a simple example of this. You will be able to understand it more clearly. Suppose I create a vector called val, which is 3, 2, 1, 0.5. And then what I do is cum sum of val. So this gives me the cumulative sums. First 3, then 3 plus 2, 5, then 3 plus 2 plus 1, 6. Sum of all the things, 6.5. And then I also compute sum of val, which is the total of everything. Now if I take cum sum val and divide it by sum of val and multiply this with 100, what do I get? The first thing, 3, is 46% of the total. The first two things together is 76.9% of the total. Similarly, if I take everything, then I can explain 100%. So I call that how much I have explained using only first few of my eigenvalues. Okay, then I am extracting the coefficients because the scores is a matrix, and I am taking the ith row, that is the scores for the ith picture. So I am going to reconstruct the ith photo using this basis. Now I am creating a plot, I am starting the plot. Then the first step that I do is just show the plot. So I am using this function raster image as dot raster y. Earlier I had shown plot as dot raster y. That is the same thing as this. In fact, I might as well just convert this to plot. That will be possibly easier to understand. So I am going to construct this in this way. So I am just plotting it. Then read line will wait for me to hit enter. So this is the starting point, the origin. Now I am going to add all those 49 contributions. So k from 1 to 49. If k is just 1, I will take the first coefficient times the first vector. That is my temp. If not, I will take the first k coefficients 1 to k, and then I will multiply this with the coefficients. Finally, I will do the reconstructions, the origin plus this thing, that sum that I got, contribution of the first k. And sometimes you might get negative values or more than one, since when you want to plot them as an image, they might cause problem. So I am forcefully making them 0 and making them 1. These are all vectors, 36,000 dimensional vectors. We do not want that. We want them to be wrapped as 200 by 180 matrices. So dimension of recons, I am setting it to be 200 by 180. And finally, I am going to make a plot. And when I am making a plot, I am specifying the particular number of components that I am using, k, the current eigenvalue, as well as the percentage that I am explaining. In fact, I could simplify all these things in much more easily by a single plot command, and I will take this and I will put it here. In that case, that will be much easier. When I write main equal to something, this is the main heading. And again, I am issuing a read line command. The read line command basically waits for me to hit enter. So let's just carry this out in practice. I will load the function. I have loaded the function, and now I am going to do show steps new chord. And which one do I want to construct? Suppose I want to construct the third photo, which I do not know what it is. So this is the very first thing that I am getting. That is the mean picture. I hit enter. Mean picture plus the contribution of the first eigenvector. Hit it again. The contribution of the first two. And in this case the percentage is not being shown. I wrote the main thing. Okay, so I do not know why it is not showing. I will hit it again, and as I am hitting more and more, you can see that the face is forming. Okay, so it just jumped into the right face, and after that it hardly changes. So you needed possibly some 10 things, 10 eigenvectors in order to explain everything. So basically it resides in a subspace of dimension 10. So that's all that I wanted to talk about in this video.